Welcome everyone. I am Arpan Mukherjee, third year student of Electronics and Communication Engineering. I am currently studying in Dr. B.C. Roy Engineering College, Durgapur, West Bengal. For the past 1 month, I have been enrolled for IoT internship at Emertxe. I would like to thank Emertxe for offering these kind of excellent internships. Now it's time to showcase what I have learned. So let's start with the presentation. You can see here I have divided the whole video tutorial into two parts. Okay, part one includes introduction to IoT, history of IoT, IoT challenges, working of IoT, reference architecture IoT, C programming, problem statement, components used, tools used in project requirements, and outputs of the system. And the second part includes final demonstration and the code discussion part. Okay, now what is IoT or Internet of Things? The Internet of Things or IoT is a network of physical objects or things embedded with electronic software, sensors, and network connectivity, which enables these objects to collect and exchange data. What are the applications? Building home automation, temperature monitoring system, energy management, smartwatch, etc. Okay, now history of IoT. In 1999, Kevin Ashton coins the term Internet of Things and established MIT's Auto ID Center. Internet of Things challenges. What are the major challenges of implementing IoT devices? Addressing scale, connectivity, data volume, device size, etc. And working of the Internet of Things, also referred as Internet of Everything, consists of all web-enabled devices that collect data and send and act on data. Okay, it collects data from the surroundings and sends them to cloud. After the processing, the data are presented. Okay, the devices, often called connected or smart devices, can sometimes talk to other related devices. This communication is called machine-to-machine communication. Humans can interact with them to set them up. Okay, now you can see here reference architecture of IoT. Okay, IP capable devices IP capable devices are directly communicating with the cloud gateway, but the existing IoT devices and low powered devices are connecting through the IoT gateway and communicating with the cloud gateway. This part is the data processing part, and this part is the presentation. I have told you that first the data is collected through the cloud gateway. Okay, then the data is being processed, and after that finally the data is presented. Okay, now, what is embedded system? Embedded system is the combination of software and hardware which is controlled by a microprocessor or microcontroller to perform a specific task. There are so many. We are surrounded with embedded systems, but among them there are three major examples of embedded systems. They are micro open, Wi-Fi router, refrigerator. Okay. Now, embedded system categories. There are few categories of embedded system. Standalone devices follow instructions blindly and takes decision by its own. Like self-driven car. Okay, real-time embedded systems complete tasks with instant action. That means airbag system. Whenever the accident occurs, the airbag system immediately activated. Okay, network devices that helps in connection, router, dongle, etc. Movable embedded system. Our mobile phones are also an embedded system, and they are movable embedded system. Okay, now embedded system building blocks. There are few fundamental building blocks of embedded system. They are power, CPU or the central processing unit, the RAM, the ROM, the peripherals or the input output devices. Okay, and the clock. And this entire system is communicating with the external world or to the user. Okay, embedded system, RAM and ROM. There are two types of RAM available, static RAM and dynamic RAM. Static RAM, volatile semiconductor memory, basic storage element is flip-flop, 4 transistor per bit of storage. Dynamic RAM, volatile semiconductor memory, basic storage elements capacitor, 1 transistor per bit of storage, periodically refreshing needed. Okay, now the ROM. ROM is the uh, storage element where it stores the firmware or the uh, instructions, okay, given by the user. It connects with the main memory, lies outside the processor and non-volatile. Okay, types of ROMs are mask ROM, OTP ROM, EEPROM, EEPROM, flash memory, and EMC is there. Okay, now C programming. C programming is a structured programming language, one entry and one exit point. C is case sensitive programming. C provides easy readability by its commands. C is powerful language. C programs built from variables, data types, functions, statements, and expressions. Okay, this is the typical skeleton of a C programming. These are the header files include stdio.h, standard input output, onio.h, console input output, and int main where we write the main code and return 0. Data types and format specifier. 4 data types are there in C programming. They are integer, character, float, and double. Okay, integer takes 4 bytes, character takes 1 byte, float takes 4 bytes, and double takes 8 bytes. Okay, 32-bit, 8-bit, 32 bits, and 64 bits. You can see here these are the format specifiers for the integer, character, float, and double. Okay, percent %d is the format specifier for integer, percent %c is the format specifier for character, percent %f is the format specifier for float, and LF is the format specifier of double. Now operators. Three main operators are there in C programming: unary operator, binary operator, and ternary operator. Other operators are arithmetic operator, logical operator, relational operator, assignment operator, increment, decrement operator, and conditional operator. Okay. Loops. Three types of loops are there: while loop, do while loop, and for loop in the C language. Okay. If conditions. There are even there are three types of if statements we have in our C language. Okay. Simple if, without else. Okay. If and else, and nested if else. That means within if there is another if. That means nested if else. Okay. Array is used to store multiple values in a single variable instead of declaring separate variables for each of value. You can see there the types of arrays we are having in our C programming: 1D array, 2D array, multi-dimensional array. Okay. Now string. A string in C programming is a sequence of characters terminated with a null character. Okay, percentage is a format specifier. For input, we use this get s for input and put s for output. And this is how we declare character string array. Okay, character and the string array name. Okay, with the capacity of the string array. Now the pointers. A pointers in C programming is a special variable which holds the address of another variable. Operators used here star and ampersand. Okay, star value at an address and ampersand address of a variable. This is the typical code snippet for the pointer in C programming. Okay. Structure. Structure is a collection of dissimilar data types. This is not a function. This does not contain any function like C++. To access the members structures, we use dot operator. Okay. This is the skeleton of a structure constructing a structure. Okay. Structure name, data type, variable name, variable 1, variable 2, variable 3. Okay. First data type and then the variable name. Switch case operators. Apart from if else, there is another statement switch operators is there, which is switch case operator. Switch case statement is type of optional operator. Okay. Based on the options, based on the input given by the user, it will perform the operation. That means if here we are taking scanf, by the scanf function we are taking input from the user and switching the x. If x equals to 1, this statement will be printed. If equals to 2, then this statement will be printed. After that there will be break. Okay. If x equals to 3, then this statement will be printed, and this is the default statement. If no one is matches with the input, then this statement will be printed. This is the problem statement of our project, which is home automation using Arduino and Blynk application. Okay. Components used in project, they are LDR sensor, temperature sensor, cooler, heater, LCD display, Ethernet shield, inlet valve, I2C module, outlet valve, Arduino Uno, and LED. Okay. Tools used in project. We are using Arduino IDE as host for developing the code and to upload the code to our target, which is Arduino Uno board. Okay. Arduino IDE we are using here as host. Simulator, that Picsim simulator. Okay, we are using here for developing our system. Okay. Virtual serial port tools we are using here for creating virtual ports, communication ports, to controlling the serial tank. Okay. Blynk application, that means the Android Blynk application as our dashboard. Okay, to control our system, and the Blynk cloud. These are our project requirements. We are having three primary requirements in our system: garden lights control, temperature control system, and water tank control and monitoring. Okay. Garden lights we will be controlling based on the sunlight has fallen on the LDR surface. Okay. Temperature control system, cooler control, heater control, and threshold temperature control. Okay. And under water tank control, we are having inlet valve control, outlet valve control, and water volume control. Okay. You can see here, these are the outputs of our system. Garden light output. Okay. You can see the resistance is high here. That means the evening condition is there, and no evening condition is there, and no sunlight is there. Okay. That is why the LED is glowing with its full brightness. Okay. And this is our initial message. While we will be starting our system, first home automation will be printed, and it will state for 2 seconds. After 2 seconds, we'll be printing the temperature on the CLCD as well as on our temperature gauge on our Blynk Iot dashboard, 27.34. Okay. You can see here cooler control on our dashboard. Cooler switch is on, and on the CLCD we are getting cooler on, and here cooler switch is off, and we are getting cooler switch is off here on the CLCD. Temperature system, heater control. You can see here heater switch is on, and on the CLCD heater switch on, and heater switch is off, and here on CLCD heater switch is off. Threshold temperature control. Okay. That means here 3 equals 34.67. We will not be letting our system to cross the temperature 35. That is why we are doing that. Okay, 34.67. It will, when it will 35, it automatically turn off the heater itself. Okay, heater off, and the heater switch, the heater switch is on here, and you can see here the heater switch is off, and we are printing heater switch is off. So you can see here water tank control, inlet valve control. When inlet valve of our dashboard is on, that means when we are enabling our inlet valve, the tank starts filling. Okay, you can see here the inlet valve is enabled, and we are getting on the CLCD inflow on. And when outlet valve is on, we are enabling the outlet valve of the serial tank. You can see here outlet valve is on. That means the tank is starts emptying. Okay, and on CLCD we are printing outflow on. Okay, now the part 2 of our video demonstration. Okay, that means the final demonstration of project and code discussion.
Welcome to the part 2 of our video tutorial. In this part, we are going to see the output of our project. Whatever I have discussed so far, that means the peripherals or input or output devices, we will visualize them in our virtual lab. Since we are creating a virtual project, that is why I will be doing all the things in my Picsim laboratory application. I will be proceeding step by step. First of all, I will be giving the demonstration of all the peripherals and their connections. Then I will be discussing the source code or our core code that we are using in our Arduino, virtual Arduino. At last, we will see our desired output. So let me take you to the spare parts option of the Picsim Lab. Okay. Let me maximize this. Yeah, you can see here, this is our CLCD. That means our liquid crystal display. This is our output device of our project, and here we will be printing all the instructions that we are going to give to our system. And let me give you an overview of the connection. Here we are using this CLCD with a I2C module. Okay, I2C module. That is why, and we all know that I2C works with only 2 pins. Actually 4 pins. VDD and ground is already connected by default, and we will be connecting this SDA with the A4 pin of the Arduino that I have already connected this here, SDA, and the SCL. SCL will be connecting with the A5 of the Arduino Uno board. Okay, and SDA means serial data and SCL means serial clock. Okay, this portion is our LED, or it is also our output device, and we are using here only one LED to illustrate the LED intensity of our project. That means we have a requirement to control our garden lights, and here we are using this LED as our garden LED light. Okay, which will be controlling by this LDR. So first let me tell you the connection of this LED. So yeah, here the D1 is connected with the third pin of our, which is also a PWM pin, pulse width modulation pin of our Arduino. Here we are connecting with the third pin of our Arduino with the LED. Okay, and you see other LEDs are not connected with the Arduino, only this D1 LED. Let me change the color. Okay, okay, blue is pretty good. Yeah, okay, now this is changed. The LED color, you can see here, has been changed from red to blue. Okay, now let me tell you the LDR module. LDR module, you can see here is this is an LDR module which we can easily get online or our local market. So the properties, yeah, here VCC, also the VCC and the VSS or the ground is already connected by default, and D0 we are not using since we are getting the analog, taking the analog input. That is why A0 pin of the LDR is connected with the A1 pin of the Arduino. I have already connected it there, so let me again connect it. Okay, you can see 24 PC1 A1. Okay, this is connected with the Arduino pin A1, which is an analog input pin, and VTH is threshold voltage here. That means after 2.5 volt it will starts working. Okay, this is our temperature system. The interesting part of this temperature system is it includes the heater as well as the cooler. You can see the fan here. This is considered as a cooler okay, and the heater is inbuilt in this temperature system. This is going this is our another requirement, which is controlling the temperature system. Temperature system includes the cooler control and the temperature control. Okay, see the properties. Yeah, the heater is the inbuilt heater is connected with the 5th digital pin of our Arduino. Okay, 5th digital pin of our Arduino. The cooler is connected with the 4th. Yeah, where it is, let me check. Yeah, PD4. Yeah, 4 is connected, 4th pin of our Arduino Uno is connected with the cooler. And since the temperature system, or here is we have the module has LM35 temperature temperature sensor, and the analog pin of the temperature sensor is connected with the A0 pin of our Arduino. A0 pin of our Arduino, you can see here 23 PC0 A0 is connected with the Arduino. Yeah, we have, and here also the power supply of the temperature system is already connected by default. VCC 12 volt ground, ground is ground. Okay, now we have completed with the connections of the temperature system. Okay, now we are remaining with the main module, which is the, you can consider it as an heart of the module. Okay, this is our Ethernet module, which will be communicating with us through the Blynk application or through the Blynk cloud. Okay, this is the main module. Since Arduino is not capable of internet connectivity, we have to use the Ethernet module, or we can use ESP32, but ESP32 is not we are using here. We are using here Ethernet module. Okay, Ethernet module will help us communicating with our system. This is the main fundamental thing of our of the system. Okay, this is what we are working for. So let me give you the connections of the Ethernet module with the Arduino. Okay, so let me open the properties. Here you can see the Ethernet module having these pins, master in, slave out, ground, master out, slave in, reset pin, SCS, INTR, and serial clock. Okay, now MISO pin or master in, slave out pin will be connecting with the 12th pin of the Arduino. Okay, ground pin is already connected by default. Now MOSI will be connecting with the 11th digital pin of our Arduino. This is also a PWM pin of our Arduino. Okay, reset pin is connected with the reset pin. I have already done the connections, so I can see, I can able to let you see. Okay, now SCS will be connecting with the 10th digital pin, which is also a PWM pin of our Arduino. Okay, SCS pin connected with the 10th pin of our Arduino. Okay, interrupt we are not using here, and serial clock will be connecting with the 13th pin of our Arduino. So we are completed with all the connections of the Ethernet module with our Arduino. Okay, so yeah, we have completed all the connections here and nothing is left. So here, and wait, I've left one thing, that is our serial remote tank. Another requirement, or the third requirement of our project, was controlling the serial tank, the outflow of the serial tank, the inflow of the serial tank, and printing the volume or the tank volume of the tank on our CLCD screen. Okay, this is serial remote tank. I have taken this. Yeah, this is our Arduino module. Yeah, this is our virtual Arduino board, in which we are uploading the sketches or the files, the hex files that will be controlling all the peripherals. Okay, now I have taken the serial remote tank I have shown you earlier. Again I will be showing that serial remote tank. From tools I have taken the serial remote tank. Okay, this is another important thing. How I have created the COM ports, let me tell you that. Where is that? Yeah, so I have created the COM port 1. You can see here COM port 1, vice versa symbol COM port 2. From this create remote bridge, I have created the COM port 1 and COM port 2. These all are virtual COM ports. Okay, these are not real, these are virtual COM ports. I mean these COM ports are not provided to me by the computer itself. I have created those COM ports virtually to communicate with the system, and rather I can say the Arduino with the serial tank. Okay, so I don't need another COM ports here, so I'm exiting the window. We are left with the code discussion part and the final output part. Okay, so you can see here, this is my Arduino IDE and all the peripherals we have discussed so far here having two individual files. One is .h file and one is C++ file. For the LDR, that is LDR.h and LDR.cpp, and main.h and tank serial tank.cpp file, serial tank.header file. Okay, temperature system.h or header file, and temperature system.cpp file. Okay, why we have to create all these files individually? Because if we incorporate all these files within one file or one sketch, then debugging the file later will be so difficult. We will not be able to debug all the things, or there are so many difficulties will be faced by us. Okay, so that is why we have created all these files individually, and later on we will be including all these files within this main file, which is home automation Blynk control. So let us start with the discussion with LDR.h. Here we are creating all the macros. Okay, so here define LDR.LDR_h and LDR sensor, macro name LDR sensor, guardian light. Okay, so here we are saying that LDR sensor, the pin of LDR sensor is connected with the A1 analog pin of the Arduino Uno, and the guardian light or the LED is connected with the third digital pin of our Arduino Uno. And here we are defining declaring two functions, which are initialization of LDR and brightness control LDR. Okay, and these definitions of this function will be we have done these definitions of these functions here in LDR.cpp. So let's take you to the LDR.cpp file. Okay, here we are including our pre-created LDR.h file as a header file, so that we can access those function names. Okay, and Arduino.h we have included here, and main.h we have included here. Okay, now the void initialization LDR part. Okay, here we are saying the pin modes of the guardian light and the LDR sensor. Since LDR or the LED light or the guardian light is an output device, so that is why we are mentioning it as output device, and the LDR sensor is an input device, so that is why we are mentioning it here input device. You see, we are controlling the guardian light based on the light sensitivity of the sunlight fade on the LDR surface. Okay, so this is an input device we are using. Okay, so now the void brightness control function we are defining here, and we have created a variable ADC_value, and the type of the variable is unsigned integer. That is why because we are dealing with the positive values, not the negative values. That is why we have created here unsigned integer. Okay, to read values from LDR, this you can see here, to read values from LDR sensor to 0 to 1023, and all the values we will be reading from the sensor will be stored here, ADC value. Okay, our created variable ADC value, here is ADC value, will be stored here, and we directly we can't use those values. We have to scale it down to 0 to 255 and reverse it to 55 to 0. Okay, now ADC value equals to 255 minus ADC value divided by 4. This formula will be scaled down the values taken from the LDR sensor, and later on we will be assigning those values to the LED light or the guardian light, and we will get the intensity according to the ADC value or the voltage levels we are calculating here. Okay, we have provided a small delay here, 100 millisecond. So we have completed with the LDR.cpp part. Now we will go to the serial tank.h part. Okay, so let me take you there. Here also the macros are defined. Defined serial tank _h, defined inlet valve, outlet valve, defined high float, low float. Okay, so all the things are defined here, and you see these are hexadecimal codes for accessing those valves or floats or volumes and enabling deselling. You can see the datasheet of the serial tank that is provided by the Picsim Lab itself. Okay, so we can access those valves or the features of the serial tanks by accessing these hexadecimal codes. They are differentiable with only one bit here. See, rest of the part is same and the one bit is different. Here the inlet valve is 0 and the outlet valve is 1. So same for the others. High float is 0 and low float is 1. Okay, now for the volume the hexadecimal code is 0x30. Okay, enable and disable. You see, high means we know 1 and low means off or 0. Okay, this is what we have mentioned here. This is the same for enable and disable. 0x0 is same, and for enable it is 1 and for disable it is 0. Okay, now these all are functions that we have declared here in the header file. And what are those? Let me tell you. The initialization of the serial tank, the enabling inlet function, enabling outlet function, disabling inlet function, disabling outlet function, and unsigned integer volume function. Okay, so let me take you this all about the macros of serial_tank.h. Now let me take you to the serial tank.cpp file. Okay, we have, as the previous, we have included here serial tank.h, serial_tank.h to accessing the functions, and arduino.h and main.h. Okay, now we have created here unsigned integer variable volume value and unsigned character type variable value h and value l. Okay, for initializing the tank we have to mention these things. Okay, serial.begin 9200, which is the baud rate of our system, and at this speed we will be communicating with the serial tank. Okay, so these are the commands through we can control the serial tank. Okay, now unsigned integer volume, this the definitions we are having. By these commands we can access the volume of the tank. Okay, serial.write volume. Okay, now while serial.available, when there will be data on the terminal, then the value h variable will be reading. Okay, and while the serial.available, when there is no value available on the terminal of the tank, their value L will be reading. Okay, now volume value equals to value h very less than 8 or value L. Okay, now we are returning the volume value. Okay, this all about the volume function. Now enabling void enable inlet, while void disable inlet. These are enabling function and disabling function. By these two commands for each of the blocks we will be accessing the inlet and outlet valves, precisely enabling those inlet valves and disabling the valves. Okay, for enabling inlet, you see here we are using serial.write inlet valve and serial.write enable. Okay, now void disable inlet. For disable inlet we are having serial.write inlet valve, serial.write disable. Okay, for the enable outlet same, and the disable outlet same as previous. Okay, nothing is different, all are same. So we have completed with the serial tank. Now we will be moved towards the temperature system.h. Here and also we have defined the macros, and let me walk you through those macros. Okay, temperature underscore system underscore h is a macro defined here, and the heater is connected with the 5th digital pin of our Arduino Uno, and the cooler pin is connected with the 4th digital pin of our Arduino. We are left with the code discussion part and the final output part. Okay, so you can see here this is my Arduino IDE, and all the peripherals we have discussed so far here having two individual files. One is .h file and one is C++ file. For the LDR, that is LDR.h and LDR.cpp, and main.h, and tank serial tank.cpp file, serial tank.header file. Okay, temperature system.h or header file, and temperature system.cpp file. Okay, why we have to create all these files individually? Because if we incorporate all these files within one file or one sketch, then debugging the file later will be so difficult. We will not be able to debug all the things, or there are so many difficulties will be faced by us. Okay, so that is why we have created all these files individually, and later on we will be including all these files within this main file, which is home automation Blynk control. So let us start with the discussion with LDR.h. Here we are creating all the macros. Okay, so here define LDR underscore h and LDR sensor, macro name LDR sensor, guardian light. Okay, so here we are saying that LDR sensor, the pin of LDR sensor is connected with the A1 analog pin of the Arduino Uno, and the guardian light or the LED is connected with the 3rd digital pin of our Arduino Uno. And here we are defining declaring two functions, which are initialization of LDR and brightness control LDR. Okay, and these definitions of this function will be we have done these definitions of these functions here in LDR.cpp. So let's take you to the LDR.cpp file. Okay, here we are including our pre-created LDR.h file as a header file, so that we can access those function names. Okay, 35 temperature sensor is connected with the A0 pin of our Arduino Uno. Okay, these are functions we have defined here. Okay, what are those? Float type function is there, read temperature. Okay, initialization of the temperature system, cooler control and heater control. You see, we are passing a parameter called control, and type of the parameter is boolean. Okay, for both the cooler control and the heater control. So we have completed with the macro part of the temperature underscore system.h. Now we will be taking you through the temperature system.cpp file. Here we have, this part is same for as the previous, so I'm not going to tell you again and again same thing. So let me tell you the what is initialization of the temperature system. Okay, here we are telling the system which is input and output. Okay, so here pin mode, heater and cooler both are considered as output. Okay, so that is why we have make them as output devices. And pin mode, temperature sensor, we are reading the temperature sensor, that means we are taking the input, so that is why here we have mentioned it as input file, input sensor. Okay, after that float read temperature, float read temperature function definition. Okay, here we are creating temperature float type of variable. Within this we are calculating or taking all the values that is being read by the temperature sensor, analog sensor, temperature sensor. Okay, and you can see the formula here. By this we are converting the value taken by the sensor and converting it to the digital values. Okay, for reading, and we are returning here temperature. Okay, to turn on and off the cooler. Now turning on and turning off the cooler. Cooler control function is the definition of the cooler control function is there, and passing the control parameter here. But if control here, if the control, let me tell you, equals to 1, sorry, equals to 1, and then we will be assigning digital write cooler as high. Okay, that means we will be enabling the cooler. Else if the cooler if the control equals to 0, then cooler will be low, or we will be disabling the cooler. So we don't need to mention here equals to 1. It will be understood by the compiler itself, or the instruction we are given. Okay, same for the heater, you see, passing the parameter as control. Okay, if control equals to 1, then we will be enabling the heater, else we will be disabling the heater. Okay, this is what we are doing in the temperature system.cpp file. Okay, now let me take you to the main.h. Okay, to control all the things we need some virtual pins from the from our Blynk Iot dashboard. Okay, so let's start with the main.h. Define, we are creating a macro here, define main.h. Okay, for our easy understanding, we have created two macros here, on and off. On means 1 and off means 0. Okay, now define temperature gauge as V1 virtual pin, define cooler pin as V0 virtual pin, heater V pin is V2 virtual pin, and we are not using here water volume gauge, that is why we have made it comment, and inlet virtual pin is V3. Okay, outlet V pin is V4, and also we are not using blink terminal virtual pin, that is why we are using V6. Okay, now we are left with the main sketch, right? This is our main sketch, and all the things we have created will be incorporated in this file through the library as library file. Okay, so this part is the definition part, title of the project, description of the project, and the peripherals we are using. Right now, for any IoT applications, 3 things is must. Those are Blynk template ID, this unique Blynk template ID, the template name, whatever the name we are giving to our project, and the Blynk authentication token. This unique authentication token is very crucial. Within this, with this authentication token, we will be controlling our system, only our system, not others. So this is a very fundamental thing. Okay, these are the inclusion of the library files. Okay, serial peripheral interface.h is an header file or the library file. Okay, include ethernet.h is another library file, and which will be which we are included here for the Ethernet board. Arduino itself is not a internet capable device, that is why we have to use ethernet.h, and for ethernet, using the ethernet.h, we have to include this library. And blinksimple.ethernet.h is another library file which will be communicating with our mobile and the IoT dashboard with our system. Okay, and wire.h is using for the I2C protocol used in the CLCD screen. Okay, and liquid crystal I2C is included for the CLCD screen. Okay, now all the things we have created here, just like main.h, all the header files we have created manually will be incorporated here. See, main.h, temperature system.h, ldr.h, serial title. If we not include them, then no function calling will be there in this system. There will be so many errors occurred. Okay, string.h, we are creating a temperature temp variable, string type temperature variable. Okay, and we are saving our authentication token, Blynk authentication token, within this character type array. Okay, and we are creating here some variables, boolean type variables, heater switch, cooler switch, inlet switch, outlet switch. Okay, unsigned integer, tank volume, and the variable is there. Okay, now we have created a class here which name is Blynk timer, and the object of the class is timer. Right, now we have created another class here, and which is liquid crystal underscore I2C, and the object of the class is LCD, and the address of the LCD is CLCD is 0x27, and 16x2 LCD we are using here. That is why we mentioned 16,2 here. Okay, so now move on to the next part, which is Blynk underscore write. Blynk underscore write is a function which will be doing the action. Okay, which will be doing the action from our IoT dashboard through these virtual pins we are passing as a parameter. Okay, cooler switch equals to parameter dot as integer. Okay, by this function we are reading the status of the virtual switch in our dashboard. Okay, and if this cooler switch equals to 1, then cooler control function will get called and it will turn on, and we simultaneously will be printing on the CLCD screen cooler on. Okay, else cooler control off. If cooler switch equals to 0, then cooler control will be off. Okay, and we will be printing cooler off. Same for the heater, we are reading the status of the virtual switch here, and if it is 1, then heater control function will get called and on will be passed as a parameter, and the heater will get turned on and we will be printing heater on. Else the opposite function, opposite operation, heater control off, and we will be printing heater off. And same for the inlet valve and the outlet valve. Okay, inlet switch equals to parameter dot as integer. Okay, if it is 1, then we will be enabling the inlet valve and printing inflow on, and if it is 0, then we will be disabling the inlet and we will be printing inflow off. Okay, same for the output virtual pin. Outlet switch equals to parameter dot param as integer, reading the status of the virtual switch. And outlet switch, if outlet switch is equals to 1, then we will be enabling the outlet valve and we will be printing outflow on, and else the opposite operation. Okay, 35 temperature sensor is connected with the A0 pin of our Arduino Uno. Okay, these are functions we have defined here. Okay, what are those? Float type function is there, read temperature. Okay, initialization of the temperature system, cooler control, and heater control. You see, we are passing a parameter called control, and type of the parameter is boolean. Okay, for both the cooler control and the heater control. So we have completed with the macro part of the temperature underscore system.h. Now we will be taking you through the temperature system.cpp file. Here we have, this part is same for as the previous, so I am not going to tell you again and again the same thing. So let me tell you what is initialization of the temperature system. Okay, here we are telling the system which is input and output. Okay, so here pin mode, heater and cooler both are considered as output. Okay, so that is why we have make them as output devices. And pin mode, temperature sensor, we are reading the temperature sensor, that means we are taking the input, so that is why here we have mentioned it as input file, input sensor. Okay, after that float read temperature, function definition. Okay, here we are creating temperature float type of variable. Within this we are calculating or taking all the values that is being read by the temperature sensor, analog sensor, temperature sensor. Okay, and you can see the formula here. By this we are converting the value taken by the sensor and converting it to the digital values. Okay, for reading, and we are returning here temperature. Okay, to turn on and off the cooler. Now turning on and turning off the cooler. Cooler control function is the definition of the cooler control function is there, and passing the control parameter here. If control here, we have completed with the heater switch, cooler switch, and inflow, outflow, or the inlet switch, outlet switch. Okay, now we will be seeing that update temperature reading. See, update temperature reading, we have to update the temperature here. Okay, for we are sending 10 data per second. Okay, we are you have seen the IoT dashboard. Okay, there is a gauge is there. Okay, so we have to update those values continuously. So for this updatation, we have to mention we have this function here which will be doing our updatation. Blynk virtual right will be doing our job. How this parameter is passing, sorry, the temperature gauge, the virtual pin is passing here, that is connected with the temperature gauge, and reading temperature is there. We are sending our reading temperature file. Okay, now void handle temperature. Within this we have a condition which is we are not letting our system to increase the temperature above 35. As soon as it crosses 35, it will off the heater itself automatically. Okay, that this is what we have done here. If read temperature increases float 35, that means float anything, float 35.01, 35.23, anything, then the heater switch will be 0 and the heater control function will get called, and the off will be passed as a parameter. Okay, blynk.virtual right will be updating our virtual switch, is connected with the heater virtual pin, and it will make it as 0. Okay, and we simultaneously will be printing lcd.print heater off. Okay, now the handle tank function. Okay, read the volume of water and compare it with 2000. Inlet valve is off and inlet valve is off. Okay, now if our total volume of our tank is 3000, okay, if the tank volume less than 2000, ampersand inlet switch equals to 0, then we will be enabling the inlet. Okay, inlet switch equals to 1, and then blynk.virtual right inlet virtual pin equals to 1, and we will be printing lcd.print inflow on. Okay, that means what we are doing here, the below 2000, when the water level is 2000, it is okay, and as soon as it starts decreasing from 2000, then we will turning on the inlet switch. Okay, then immediately the inlet switch or the inlet valve will get turned on. This is what we are doing here, and another condition is there, which is tank volume equals to 3000, ampersand inlet switch equals to 1. If that means I have told you that our capacity is 3000, and if it reaches its tank capacity, then we will be disabling our inlet valve. Okay, and we are making here, see, inlet switch equals to 0, and we have to update this. So by blynk.virtual right we will be updating the virtual switch. Okay, and we will be printing simultaneously lcd.print inflow off on the CLCT screen. Now we are left with the setup portion, which is we have to communicate with the serial tank, since this is serial remote tank. That is why we have to start the serial communication by this statement, serial.begin. This is the baud rate, nothing but the baud rate, 19,200. Baud rate is the data transmission rate. Okay, now we are initializing the LED by we can access the all the operations by this object we have created earlier. Okay, lcd.initialize. Okay, initialize.backlight, initialize.clear, initialize home, initialize set cursor, initialize.print. At first, while starting our system should print home automation. After this 2000 millisecond or 2 seconds delay is there, then all the things will get cleared, and we'll be printing T on the first row for the temperature, and V for the volume of the tank on the next row. Okay, now here this is the initialization part for the LDR, that means the pin modes of the LDR and the garden lights, and initialize temperature system is for the temperature system, which we are mentioned in this file. Okay, yeah, pin modes, heater, cooler, output, inputs is mentioned here. Okay, and this timer set interval is for the timer. I have already told you that 1 second 10 data per second. This is what we are doing here by this timer set interval temperature reading. Okay, and to establish the connection within the mobile phone with our system, we have to mention it blynk.begin, just like serial.begin, serial communication, here blynk communication. Okay, blynk.begin we are using here, and blynk authentication token we are passing as a parameter. Okay, in the void loop portion we are calling the brightness control function again and again in order to control the intensity of the light based on the sunlight. Okay, now temperature variable we have created earlier, string. Okay, string we have to make the values taken by the analog sensor or the LDR sensor, sorry, temperature sensor, and have to make those as string. Then only we will be able to print those values on CLCD. Otherwise, we will not be able to print those values. This is why we have taken string here, and two fields will be considered after point. Okay, and here set cursor 2,0 temperature we are printing here, and handle temperature is calling here. Okay, for the tank volume, here volume function is calling here. We are calling here, okay, lc.print tank volume. Okay, this is for the printing of tank volume. And timer.run, we have to initialize the timer.run, otherwise this timer.set interval won't be work. Okay, we have to mention it here, timer.run. And to establish the connection, to make sure the connection between the IoT dashboard or our mobile phone and the system or our home automation system is continuous, that is why we have to mention it here, that blynk.run. Blynk.run will connect the device continuously to the cloud. Okay. We have completed with the heater switch, cooler switch, and inflow, outflow, or the inlet switch, outlet switch. Okay, now we will be seeing that update temperature reading. See, update temperature reading, we have to update the temperature here. Okay, for we are sending 10 data per second. Okay, we are you have seen the IoT dashboard. Okay, there is a gauge is there. Okay, so we have to update those values continuously. So for this updatation, we have to mention we have this function here which will be doing our updatation. Blynk virtual right will be doing our job. How this parameter is passing, sorry, the temperature gauge, the virtual pin is passing here, that is connected with the temperature gauge, and reading temperature is there. We are sending our reading temperature file. Okay, now void handle temperature. Within this we have a condition which is we are not letting our system to increase the temperature above 35. As soon as it crosses 35, it will off the heater itself automatically. Okay, that this is what we have done here. If read temperature increases, float 35, that means float anything, float 35.01, 35.23, anything, then the heater switch will be 0, and the heater control function will get called, and the off parameter off will be passed as. Now let me give you the actual demonstration of the project. Okay, you can see here I have casted my mobile screen on the computer screen. Okay, and now we'll open our Picsim Lab and we'll see the output. Okay, yeah, you can see this is our Arduino Uno, virtual Arduino Uno. Okay, working on 16 megahertz clock speed, and this is our peripherals terminal. Okay, peripherals terminal. Let me open the Blynk Iot app on our mobile phone. Okay, now let me give you the actual demonstration of the project. Okay, you can see here I have casted my mobile screen on the computer screen. Okay, yeah, you can see here our system is online. I have casted my mobile screen on the computer screen, and you can see here, and my device name is Pluto, which is showing online here. Okay, and these all the connections I have shown you earlier. This is let me tell you once more time. This is our Ethernet module, this is the I2C module, this is our CLCD, this is the output, this is the cooler system, the temperature control system, and this is the LDR. Okay, this is our virtual Arduino Uno. Okay, now first, according to our first requirement, let me show you the output of the LDR. Yeah, you can see here our system is online. I have casted my mobile screen on the computer screen, and you can see here, and my device name is Pluto. I have configured all the things, and now it should be working. You can see here I am changing the resistance, because this is not working. I don't know. Yeah, you can see as per the when I am decreasing the resistance, that means sorry, yes, I am decreasing the resistance, that means sunlight is very high and the intensity should be and this is the daytime, and the intensity should be very low or almost off. Okay, and when I am increasing the intensity, that means this is the night time, and yeah, it is the night time and the intensity of the garden lights would be very high. I have configured all the things and now it should be working. You can see here I am changing the resistance, but this is not working. I don't know. Okay, so this is our first requirement. Now we will be turning on the cooler system. Okay, first of all let me turn on the heater, then we will turn off on the cooler. Okay, this is, you can see here, here we are printing the temperature and here we are printing the volume of the tank. Okay, I am turning on the heater on my Blynk Iot application or in our dashboard. Okay, see, you can see here heater is on, is printed on the CLCD, and you see simultaneously the T is increasing. T is increasing here. Temperature, you see, is increasing here. You can see also in the gauge from 30, 32, it is increasing the temperature. Okay, maximum value is 100 and the minimum value is 0. You see 35.16, 35.16. At the time the cooler is, sorry, the heater is automatically turned off. We didn't manually off it, but it automatically turned off. Let me turn on it again so I can show you one more time. 34.67, 35.16. You see, this is automatically offed. Okay, now we will be turning on the cooler switch. See, cooler on. Yeah, cooler on. See, the fan is working. Fan is turning on. 1 minute. Okay, so this is our first requirement. Now we will be turning on the cooler system. Okay, first of all let me turn on the heater, then we will turn off on the cooler. Okay, this is, you can see here, here we are printing the temperature and here we are printing the our cooler is on. See, cooler is on and still the fan is working, and simultaneously we are printing here cooler on. Okay, cooler, so temperature system is working fine. Okay, now the temperature here we are printing on the gauge. Let me turn off the cooler and turn on the heater. You see, cooler is off, and the temperature is increasing on the CLCD as well as on the gauge, is increasing. Okay, see, heater off. I have off the heater. Okay, now we are left with the serial tank part. Serial tank part, I have showed you that we have created virtual pins, virtual communication ports, COM1 and COM2. The serial tank is connected with the COM2, and our Arduino is connected with COM1. Our cooler is on. See, cooler is on, and still the fan is working, and simultaneously we are printing here cooler on. Okay, cooler, so temperature system is working fine. Okay, now see, I will be turning on the inlet valve in order to fill the tank, and later outlet valve. Okay, you see the output of the CLCD screen. Okay, CLCD screen you saw, because the terminal is not available here on the IoT dashboard. I am turning on the inlet valve. See, the serial remote tank is working fine. It is filling, and inflow is on. Here you can see on the CLCD, inflow is on. See, here we are printing the volume of the tank. You can see here, there. See, 2890, 3000, and it is completely filled. Now I will be turning on off the inlet valve. Inlet valve is off. See, inflow off. See on the CLCD, inflow is off, and also the Blynk Iot dashboard, inflow is off. Now I will be turning on the outlet valve. See, the volume of the tank is decreasing. Outflow on. See on the CLCD, outflow is on. Outflow on. Sorry. Yeah. Outflow on. It is completely the water is completely decreased. Okay. See, the volume of the tank is decreasing. See, outflow off. So you see everything is working perfectly. Everything is working perfectly. Okay. Yeah, the intensity is also working perfectly. The lower the resistance, higher the sunlight. Okay, and higher the resistance, lower the sunlight, lowest the sunlight. Okay, so this is the evening condition, and when the resistance is very low, this is the morning condition. Okay, see, outflow off. So you see everything is working perfectly. Everything is working perfectly. Okay, you can see here. Let me turn on the heater and let me increase the temperature a little bit. Okay, see, temperature is increasing. Temperature is increasing. Heater is off. Now the temperature is 33. Now I will be turning on the cooler, and you see the temperature is starts decreasing. See how fast the temperature is decreasing by turning on the cooler. Okay, so everything is working completely fine. Okay, so this is what we have worked on, and this is the ultimate thing and the output of our
I would
project.
like to conclude the video presentation. So using Blynk Iot application and Picsim Lab simulator, we have completed our entire project, that is home automation using Arduino and Blynk Iot application, where LED temperature system serial tank resembles light, heater, cooler and water tank in real time. That means we are controlling those in real time. Okay. CLCD acts like dashboard used for displaying the events. Okay, widgets from Blynk IoT app like button widgets are used to control heater, cooler and inlet valve, outlet valve. Okay, gauge widgets, gaze widgets to display the temperature. Okay. Now I would like to thank the team Emertxe for offering this kind of internships, and I will be looking forward to do other internships from Emertxe. Thank you.